Hello and welcome to another Haas tip of the day. Now this is our second probe troubleshooting video. Today we're going to go through a handful of additional troubleshooting tips that'll go a long way to making you a probing expert. Now in our first probing video, we looked at the most common root causes of probing problems. Things like low batteries, probe calibration, and probe macros. Today we're going to look at some of the other things that can cause us grief when probing and show you how to fix them. Now when replacing the batteries in your probes, remember, not all batteries are created equal. Be sure to use the type and brand of batteries recommended by Renishaw. Not all brands of batteries are suitable for your Haas probes. If you put the wrong brand or type of battery into your probe, it just might not work. Now I just changed the batteries in my probe and it's time to put it back in the spindle, but I don't remember which way it was oriented when I pulled it out. Now this is why Renishaw recommends that we dial in the tip of our probe to within 2.5 microns. That's just 1/10 of a thousandth of an inch. That way, if the probe gets pulled out and put in the opposite orientation, it won't affect our accuracy. Now if you're switching your machine between inch and metric mode using setting 9, be sure to recalibrate your probe. If you don't recalibrate your probe, your machine's going to give you an alarm, just telling you that you have to recalibrate. Now, all of our probe calibration values are stored in the control as macro variables. If we zero out all of our global macro variables, we've just lost all of our calibration. If you've done this, no big deal, just go ahead and recalibrate your probes. Along these same lines, if you zero out all of your tool length offsets, you'll have zeroed out the tool length offset for your spindle probe as well. Now, if you've got a next-gen control, they've given us a new feature, a way of protecting the tool length offset for our spindle probe. All you have to do is define your tool type for your spindle probe as a type 7 probe. Then, if we press the origin key and arrow down to clear tool offsets except probe and make that selection, it'll zero out all of your tool length offsets while protecting the offset for your spindle probe. This is a nice feature. Now here's a probing issue that you're likely to run across at some point. I've loaded a 7.5 inch diameter slug of aluminum into a vise and placed it on my mill. Now all I wanted to do was probe the center and write that value to a work offset. So I went to my offset page, I followed the on-screen instructions, filled in all the blanks in order to probe a boss. But when I hit cycle start, my probe didn't probe like it was supposed to. It took a few points and then gave me a probe fail alarm. Probe fail, what is that? Well, does that mean we need to replace the probe? Thousands of dollars? No. The root cause is a lot less sinister than that. All this meant was that I wasn't close enough to the center of my part when I hit the green button. Now to fix this, we're just going to use a machinist scale and a permanent marker. We're going to find a better approximation for the center of that part. I'll jog my probe above it. We'll run the cycle again and see if it fixes our problem. So far so good. It's made it past the point it failed last time. That's it. It wrote to my work offset, and all we had to do to avoid that alarm was find a better approximation for our starting point. Now, if you walk up to your machine and you don't know what tool number your spindle probe is, you can find out pretty easily. Just look at your macro variables page and look at macro variable 560. This is going to contain the tool number of your spindle probe. Right now, this machine is set up as tool 10. If we wanted to set our spindle probe as tool 24, we can do that pretty easily. All we have to do is pop out the spindle probe, put it back in the machine as tool 24, and recalibrate. The control is going to update macro variable 560 automatically during the calibration process. Now we're back up front in our demo room. We're going to give you another tip here, something you need to be aware of when probing. Now all these tips are related to troubleshooting your wireless probing system. The key word there is wireless. Our table probes and our spindle probes communicate with our OMI, our machine interface, using infrared. That signal is line of sight, meaning that our table and our spindle probes need to be able to see the OMI in order to communicate. If something gets in the way, it's going to block that signal and we're going to have problems. Now, the top culprits that cause us this interference are tall fixtures, rotaries and trunnions, and sometimes it's just that we haven't cleaned the glass on our probes and our OMI. Now, with our table probe, we've got some simple solutions. We can move that probe from one side of the table to the other, if that's going to solve our problem. If the table probe is just too low, too close to the table, we actually sell a probe riser block that'll give us some more clearance so the signal can get up and over that fixture. Just be sure to recalibrate that table probe when you're done. For the spindle probe, we have a little more difficulty. You just simply have to make sure that your fixtures and your rotaries are placed in a position where they don't block the signal. Worst case scenario, you can buy longer tips for that spindle probe. Now, if your problem is just concentrated coolant and chips building up on your OMI and your probes, that's easy also. Just take a clean, soft cloth and wipe off those windows. And this is something we should be doing on a regular basis. Well, that's it for today's probe troubleshooting tips. Now, we do have some cool stuff for you in today's bonus content, so be sure to check that out. And for more Tip of the Day videos, be sure to subscribe to this YouTube channel. Thanks for watching this Haas Tip of the Day.